Hey guys, welcome to question FM306 of the Further Maths Fortify study guide. This question reads, NBA player Kevin Snake Ranch shoots a basketball at the ring in a perfect circular arc from point K, which I should put here, from point K, which is at the same height as the basketball ring, 3.05 meters above the ground. Russell Herobrook is attempting to goaltend his shot by intercepting at point P. Point here, as shown in the following diagram, and then we're given a diagram that's much more intricate than this, but what I've actually listed here are the important details that you will need in order to answer this question. The vertical distance from P to the basketball ring is 0.61 meters, which I've put in here, and the radius of the arc made by Kevin's shot is 3.4 meters, and that's in here. Assume that the referee ignores Russell Herobrook's illegal goaltend because they don't respect Kevin Snake Ranch at all. The distance the ball travelled along the dotted arc in meters before interception at point P is closest to what? So what we're trying to find is this length along here, this circular length between K and P. So in order to answer this question, or in order to find any arc length, we are going to need a few pieces of information. So first of all, we have the formula, 2 pi r times theta over 360, or something like that. It might be the other way around, doesn't matter. And the two unknowns that we have here are the radius of our circle and the degrees that it travels along. So what I mean by that, our radius is going to be 3.4, so r for this question is going to be 3.4 meters. However, it's going to take a little solving in order to figure out what our unknown angle here is, because if we look at this here, this is our unknown angle in here. So, how do we figure out what this unknown angle is? Well, we don't really have any tools inside this circle to help us out. However, we do have this 0.61 meters over here. And that's helpful because in order to figure out what this angle is, we could look at theta, or theta being we could look at having 180 degrees, so the length would take all the way along here, and minusing whatever this amount is here. So 180 minus x degrees. So we'll do a little solve for how you'd figure out what this little degree is in here. And we're going to do that using trigonometry. So we're going to set up a little right angle triangle here. Now, what we know about this little right angle triangle, I'm taking it from this position here, is that it's going to have an angle of x, our unknown that we're solving for, which means that this side is going to be the opposite, and it has a length of 0.61 meters. And you may be tempted to put the 3.4 meters down here. However, that would not be true because remember, this is a circle, so it would continue out here. And what we have is a straight line, so it wouldn't follow that circular arc. Our 3.4 is actually going to be the hypotenuse because all distance from the radius to the circle, from the center of the circle to the end of the circle, or the edge of the circle, is going to be the same length as our radius because it is effectively just another radius. So from here, we have the opposite and we have the hypotenuse, so we know that we're going to be using our sine formula here. So sine theta is equal to opposite over hypotenuse. Substituting our values in here, we get sine of x is equal to 0.61 over 3.4, and rearranging that one more time, we get x equals sine of -1, 0.61 over 3.4. We get this rearrangement here. So substituting our values and then rearranging for our unknown, we get x equals sine -1 over 0.61 over 3.4. So we can substitute this value of x back into our little formula over here for theta, and then we can substitute our values of r and theta back into this original arc equation. So now we know that theta is going to be equal to 180 minus sine -1 0.61 over 3.4, which means in order to calculate our arc is going to be equal to 2 times pi times 3.4. So substituting r for our r value 3.4, and from that we're going to minus theta, replacing that with our value that we found here. So 180 minus sine of -1 over 0.61 over 3.4, all over 360. Putting this little expression into a calculator should drop a value, or should drop out a value that is 10.1 meters when rounded to the first decimal place, which is looking a lot like option A. If you guys have any questions about this question, please drop them in the comments below. Otherwise, I'll see you in the next video.